This is recording 1F in our series on quadratic functions in vertex form for Unit 3, Chapter 3 of Mathematics 2200. We're going to focus on how we can use the values of a and q to determine the number of x-intercepts for a quadratic function. Example 1. We have this function y equals 2 outside of x minus 3 squared minus 4. We want to know how many x-intercepts it will have. We're not interested in what those x-intercepts exactly are, just how many are there. The vertex, PQ. Well, remember, our vertex goes by the p-value, which is the opposite sign of the number in the brackets here with the x, and -4, which is our q value. So our vertex is at 3, -4. Now, because the q value is negative, therefore the vertex must be below the x-axis. Let's actually do a mental picture, get a mental picture of where that vertex is. It's at 3, -4. So this should be going on inside the head. Vertex 3, -4. Now, if our graph opens away from the x-axis, so it has a vertex here and opens down, it cannot have any x-intercepts. But if it opens up, it can have 2. Let's see what our direction of opening is. Well, we have an a value equal to 2. So therefore, the graph opens up, because that a value is positive. So a is positive, therefore our graph opens up, and our vertex is below the x-axis. So this graph, I'm only roughly sketching it, must have 2 x-intercepts. Okay, if that had been a -2 for the a value, the graph would have opened away and there wouldn't have been any x-intercepts. This next example is a little bit more vague to start. A quadratic function is in the form y equals a outside of x minus p squared plus q, where a is less than 0 and q is greater than 0. How many x-intercepts does the graph have? Let's see what a less than 0 means. That means a is negative. Therefore, the graph opens down. So I've actually answered the second question here. Graph opens down. A less than 0 opens down. Is the vertex above, below, or on the x-axis? Well, our q value is greater than 0. It's positive. So wherever this graph is, wherever its vertex is, it has to be above the x-axis. So there's a bunch of places it could be, but we definitely know that it is above the x-axis. So the vertex is above, and the graph opens down. So therefore, once again, we have 2 x-intercepts. For our final example, we're told that the a value is -3 and the q value is 0 for a function that's in vertex form. Is the vertex above, below, or on the x-axis? Well, we're told the q value is 0. So if the q value is 0, that means that the vertex should be on the x-axis, right on it. So it doesn't matter where it is, the vertex must be on the x-axis. Okay, the p-value slides it left and right, so we have the vertex is at p and 0, basically. So I'll mark that down here, vertex p and 0. Now, the direction of opening, we're told a equals -3, and the graph opens down. But you know what? In this case, it doesn't matter if it opens up or down, because if the vertex is on the x-axis, there can only be one x-intercept. That's all we can have. That concludes the examples. So to summarize, if the values of a and q are known for a quadratic function, y equals a outside of x minus p squared plus q, the number of x-intercepts can be determined. Think about whether the vertex is above or below or on the x-axis, and then think about the direction of opening and what makes sense for the number of x-intercepts.